but it weighed 190.4 pounds, 215 pounds.
Oh, really?
It weighed 216 pounds. It's 241 pounds.
Welcome back to BarryTsGarage. I'm just outside Steve Coppock's shop, and we're going to have a look at the French Ford Flathead. Steve has one he's going to show us, and I brought Ed Smith along, so it's going to be a treat, and looking forward to showing you what we learned. Steve, we're at your garage actually, and you have a special treat for us today. Tell me about what this engine is right here.
Oh, well, thanks, Barry, and welcome back as always.
Yeah, thank you.
So I know you've had a few questions, and I've had a few inquiries myself about the French Flathead block. And I happen to have one, so we brought it out and put it on the stand today. I'd like to talk about it. I think people might learn something new. I will tell you, I don't claim to be an expert on this.
Okay.
I've only had this block. I've read about them for over 20 years. I know they've been out there, but I've only had this block since about January.
Okay.
And so I've done some research before then and quite a bit of research since. And I think there's still some things I don't know.
Yeah.
But I will tell you what I have looked at and what I have done.
I've already got a question before you start into the history.
Go ahead.
How did you come about this, and what condition was it in when you got it?
Oh, thanks for that. So I saw it, well, they're out there. I mean, if you went on the internet and Google it, you would find French Flatheads, and you know, there's people that have these blocks, complete engines, a bunch of new old stock crankshafts, rods, bearings.
Okay.
They're out there.
Okay.
So there's a gentleman in Wisconsin that has quite a few of them, and he was coming out to the blocks, and he was coming out to the Grand National Roadster Show, which I was going to anyway.
Mm-hmm.
And so we were able to work out a deal. He brought the blocks, and I was able to pick them up directly from him.
Okay.
So this is the condition, though. It's a new old stock. This block has never been assembled.
Wow.
In fact, you'll see as we video it, it still has some Cosmoline on it. I cleaned it best I could, maybe not the best I could, but for the video,
yeah.
When we flip it over especially, there's some Cosmoline on the underside of this block.
Okay.
So never assembled, brand new block, which for me is exciting because, you know, I deal with a lot of rusty, cracked, blocks, and it's a bit of a pain. Ed Smith's sitting here with us today as well, and Ed knows the pain of dealing with flatheads. Probably half of them that I take apart, and I bet Ed sees the same thing, are no good. You have to throw them away. And so for me, it's exciting. I plan to build this motor eventually and put it in my personal 37 Ford coupe and probably supercharge it. And so I'm excited to have a good foundation to build from.
Excellent. Yeah. And just real quick, I don't want to keep backing you up.
That's all right.
But for those who don't know what Cosmoline is and what it does, let's just cover that real quick.
As I understand it, it's a wax-based product that was put on machined metal parts. They use it on guns and car parts and tank parts and others. And it's there to preserve the metal and the finish that's on the metal while it's in storage or transportation. You have to clean it off. Yeah. And before you can use it, but it's a preservative.
Okay.
That'd be what I'd say. Ed, anything to add to that?
Yeah, same thing. It was for stuff that we stored a lot of times and shipped overseas. It would keep the salt water off of them and any kind of corrosion and things like this. It's just a matter of getting it off. And I don't know of a chemical right now that would wash it right off simply. But I think we have to do a little testing on that. But Cosmoline was on everything.
I hope people that watch this video will comment on it, because what I've found is figuring out the history of this is a little vague. I think I have some good facts here I'm going to share, but others may know more detail than I do. So I'd love to learn from anybody that happens to know better than I do.
Yeah.
But Simca, S-I-M-C-A, a company in France, automotive manufacturer in France, is sort of the origin of where these came from. There's a lot of things that happened between Simca, the company being formed in 1934, Simca, but a subsidiary of Fiat.
Okay.
So they started up real, in my opinion, just reading about the guy that was the CEO of Simca for about 3 decades, about 30 years. A real interesting guy, entrepreneurial guy. I was fascinated by him personally. So they came out with some cars prior to World War II in Europe, mostly smaller cars, right? But after the war, the factory that they were using was in pretty good shape. It came through the war in pretty good shape. And so they had a good start after the war, and the CEO had aspirations to grow the company. So he started acquiring companies that he could that were for sale, because some of them after the war really weren't in any shape to continue on in business.
Yep.
And so a couple of companies, and I'm not going to catch them all, but I think in the story of the block we have here in front of us today, one of the companies they bought, and it was in 1951, was a company called Unic, U-N-I-C, and it was a truck manufacturer in France.
Okay.
Simca was cars, so by buying Unic, they were able to start to make trucks.
Okay.
And probably the most interesting thing for me relative to Flathead story is in 1954, Simca bought Ford of France.
Ah.
So Ford had a presence in France, had a factory, probably the most modern factory in France. And Simca was able to buy the factory, but also they bought the whole subsidiary of Ford, which let them keep all of the products that were being manufactured in France at the time.
You said 1954.
1954.
That's a significant Flathead year.
That's right. So in France, Ford was making a smaller car that had the V860 in it. Ah. What we call the V860. They had another name for it, but that's the motor that they had in their smaller car. But they also had some slightly larger cars that used the more traditional style Flathead that we're familiar with here. So the 85, 9,500 horsepower type engines. So in 1954, assuming France had the same products that the U.S. did, and I don't know that that's true,
yeah,
it would have been an 8BA style motor in 1954, right?
Okay, yeah.
Because they made 49 to 53 was the 8BA.
Mm-hmm.
So I'm assuming it's an 8BA, but don't know. Around the end of 1950s, so they bought Ford France in 1954, there was a group of companies that came together for Simca, Unic, which was owned by Simca, and then Harman, a company called Harman, and I think it's the same Harman that makes drivetrain parts here. I think they're in Indiana. But I think it's the same company, maybe a French subsidiary, I don't know.
Mm-hmm.
But they made axles, especially four-wheel drive type axles.
Yeah.
Bouquet, I think that's how the French would say it.
Sounds right.
So bouquet to me, bouquet.
Yep.
So four companies came together to make a truck, Marmon trucks.
Okay.
Not Harman, Marmon. And if you Google it, you'll find the Marmon name more than you'll find the other, which is SUMB. That's the acronym. SUMB is what they called those trucks. In 1959, I think it was, that company, that conglomeration started supplying these medium-duty trucks, four-wheel drive, flathead V8 trucks to the French military, 1959. And they did that until 1973.
Really?
Yep, so for quite a while. So this conglomerate, SUMB, made these trucks from 1959 to 1973 and supplied them to the French military. In 1973, that conglomerate sold the tooling and everything to Renault, and Renault continued to support those up until the mid-90s and began to convert those trucks to diesel powered. They sort of abandoned the Flathead after a long time.
That's right? A long time.
Into the 90s. When they started putting diesels in the mid-90s, early to mid-90s, there was some need for Flatheads, but I think this is an assumption, is what would happen if somebody came in with a bad motor, they'd just put a diesel in it. They wouldn't repair the Flathead so much. So all the spare parts that accumulated, so complete engines, blocks, crank rods, pistons, probably starters and generators and things like that, became surplus. And I believe it was owned by the government at that point. I don't think Renault had like a big surplus. I think it was French government at that point.
Right.
And so it became surplus and were auctioned around the year 2000.
Okay.
And so there's a story there that's not real easy to follow, but there's at least 3 guys in the United States. I wouldn't say they worked together, but they were aware of what was going on in France, and they wanted to bring these surplus parts to the United States.
Okay.
And I'm sure there's other countries that wanted to do the same thing, and I don't know exactly who got what or whatever. But a lot of these parts were imported into the United States, and I believe that most of them initially ended up in Kansas. But they sort of disappeared from the internet anyway. I used to be able to go to the couple of websites and just order one, and it would show up at your house.
Oh, really?
I've continued to look for them. Occasionally you'll see one on eBay that somebody bought and changed their mind on. And then now there's some people that I understand have bought some of these and are selling them again. So imported around the year 2000, so 25 years ago when these came to the United States.
Yeah.
And then, you know, they're just out there. I don't know how many there are actually.
Okay, so they stayed in production way later than most of us would have ever imagined. Do we have any understanding of the actual production numbers of all those?
I do not.
Apart from it being a fresh block that hasn't been built on, are there any other differences from what we know of as a flathead?
Yeah, I'd like to talk through that if you'd let me.
Yeah.
And, we'll start, I guess, maybe at the top and work our way down.
Sure.
I did order a book, and I was hoping that it would get here in time for this discussion, but there's a guy, it's a small book, but how to prepare one of these, you know, for hot rods or whatever, you know, because there are some differences that are important.
Okay.
So I don't have that reference. I have my own reference, and I have a bunch of blocks to compare to.
Okay.
So we'll talk through that.
Okay. Now you are a great researcher and a studier of things. What have you done to look into this?
Well, one of the things I had heard when I was looking to buy these years ago was that there's more metal in them.
Okay.
And somebody said, well, they're 25, 30 pounds heavier than an American flathead. And I'm thinking, well, it's basically the same package. How could it be that much heavier?
Right.
So I have plenty of samples around here that I could check. It is a little different to compare because the French flathead is a mixture of the American designs. The block, if you will, this part of it is an 8BA.
Okay.
So 49 to 53 style.
Uh-huh.
It has the extra bolt over here on the passenger side that the 59 doesn't have.
Okay.
It has the water pump bolt pattern for the 8BA, which has another bolt right there.
Yep.
But it has a cast-in bell housing like the early motors had.
Right.
So from 32 all the way up to 48. So it's a mixture of the early, what we called Series 1 and 2 motors, and the 8BA style motor.
That's interesting.
So I don't have any around here that are exactly that combination.
No, you wouldn't. You couldn't possibly.
So
even though you have so many stacked up.
So I measured, or I weighed, I actually put a lift plate on, and I have a scale and my engine hoist, and I weighed all 4 of these.
Oh, okay, great.
So and this is really in no particular order, but I weighed this block right here, which is we know it has the raised intake surface, so we know it's 41 or 42. And this includes my lift rig, but it weighs 11.5 pounds. So if somebody wants to be real precise, they can 11.5 pounds off of these.
Okay.
But it weighed 190.4 pounds.
Okay.
And I weighed 3 times, and I took the middle one.
Okay.
So, but there wasn't more than about a half-pound difference. So let's just call it 190 pounds.
190. Okay.
The next one I measured was an 8BA, like this one right here.
Okay.
And so they made those from 49 to 53. And I figured, we hear that they probably had more metal in them, better castings, and I thought maybe that would be a heavier motor. And turns out, even though it doesn't have the extended bell housing, it weighed 215 pounds.
Oh, really?
So 25 pounds more than this one.
With the bell housing.
With the bell housing.
That's crazy.
It is kind of crazy.
Okay.
So, but then I thought, well, the 59 style, which is behind Ed there, so that's a 59 block. 59 meaning post-war, so 46 to 48.
Yep.
And it weighed 216 pounds. So not much difference than the 8BA.
And was it a little bit more? I'm trying to keep track.
It's 2 pounds more.
2 pounds more.
Or
I'm
1
going to
pound
give that
more.
to the bell housing.
Yeah, well,
Maybe.
the 8BA has a pretty heavy duty bell housing on the back.
Okay.
Or, you know, flange where the bell housing bolts. So this block weighs 241 pounds.
Whoa.
241.
Okay.
So I'm not a mathematician there, but, and I don't know which one to compare it to, but, you know, it's 20 to 25 pounds more than the heaviest block that I measured.
That is significant. That's not just a little bit.
Yeah.
Wow.
I'd heard numbers up around 35 pounds, and I can't confirm that, I don't think.
Mm-hmm.
But if it didn't have the extended bell housing on it, I don't know. It's relatively thick, but it could weigh 20 pounds. 15 pounds.
We just get a cutting torch, cut that off, and weigh it.
Yeah, I'm not going to do that.
Okay.
So there you go.
Yeah.
So then I started looking. Well, where would that metal be? And I know it could have better metallurgy, so it could just have better steel in it that's heavier. I probably does.
The Hemi motor's got more nickel in it and weighs more than a 440 motor, and they're both the same size. So the nickel in it, the motor can get hotter and colder without cracking.
I see.
So I think in my assumption there that they put more nickel in this motor.
I see.
In the mixture when they poured it, because they know that the other one's all cracked.
Right.
And it surprises me that they ran that motor this long, and we always talk about, oh, everybody's got it. If you got a flathead, it overheats.
Yeah.
So I'm sure they had some kind of thing in those trucks and those cars to keep this motor from overheating.
Mm-hmm.
Maybe a different radiator or system somehow, because if they had this overheating claim that we've had since 1932, is that they did something about it. If you'd actually take some of this somehow and sample it, it'd be more nickel than this and all the rest of them.
Yeah, that would be interesting.
I would think so.
Yeah.
So I want to show a couple things. I'm going to spin this around to Ed.
We're
going to put him on the spot.
I don't see so much in this. I haven't looked at it that much as this. The fine machining on this, if it's machined finer with the higher nickel,
oh, I see.
then it would be, the other block would be coarser machining in it.
So the same machining on different blocks, you can tell the difference.
Nickel in it would be
depending
a
on
finer machine, like a fine precision, the grain in the material.
Interesting.
So I'm thinking that's probably so. I haven't looked at that much, but they did some fantastic job on this this motor.
Yeah.
As far as machining, much more superior than Ford ever did.
Okay.
I'm sure they did because they want it to last longer and run better. Yeah.
So I went looking. So I understand the metallurgy, and I tend to agree with Ed, although I can't prove it. That's my feeling too.
Yeah.
But I got a couple things where I did find more material, so I want to show you too.
Yeah, let's see that.
And I found some where there's less.
Okay.
So we'll talk about that too.
Okay.
But it's almost like we joke about it, but there's always a place on a flathead block where the deck cracks. Right here.
Yeah, right here. Yeah.
So look how they've put more meat right there.
Oh.
This hole here used to be round.
Yeah.
All the rest of them. So they increased this top level here between here and here so it don't crack.
So they've got more
arrow there. All Fords cracked here. That was just a given thing. They said it was always a Ford crack.
Yeah.
Came to the factory cracked.
Didn't really hurt anything, right?
Don't hurt a thing? Oh, absolutely not.
So
it's all good stuff.
Because both these holes go into the same water jacket,
that's
right?
That's right.
Yeah.
But there's definitely more material there, quite a bit actually than. And if you
I'm just going to go ahead and grab this. There you can see the difference. You're right. The obvious difference. Yeah. Okay.
And here's another area. See, that hole right there is normally round, but the block thickness is thicker, so that the bottom of that hole is even cut off.
Yeah.
Yeah.
So
again, more material.
More material there.
More material.
And Ed and I came across a block one time. I thought I had a block that Ed needed, but he turned it down because of how thin it was up here around the water pumps. And I'll show you this.
Okay.
So right here is where the water pump bolts. And so this flange right here is pretty thin.
Oh, I see.
It's, I don't know, 1/16 of an inch maybe.
Yeah.
So run over there and look at the same area on that French block.
Okay.
I'll spin it around.
Oh my goodness. It's more than twice, I would guess.
That's a 1/4 of an inch or more.
Yeah. Way more.
Way more material there, right?
Oh yeah, wow. Yeah, it's almost 1/2 inch. Yeah.
It's a lot, right?
Thicker.
That's a lot.
So there's definitely more material in places like that.
Yeah. And exhaust, again, there's that exhaust port. Have you noticed that if this exhaust port is further away from here, not really, is there?
It's about the same.
And this looks the same down in this casting between here and down behind the water pump.
It looks nice to look down in there and not see a speck of
no,
rust.
no rust. No rust.
Or wires, right? Because you always see wires down in there
they always put
from
wires
the casting.
It almost looks to me, now you guys are the experts, but it almost looks to me like compared to this block, that they just added a 1/4 inch of thickness just on everything,
face.
the whole thing.
Yeah.
Yeah, possibly in the whole,
The whole face of it, yeah.
Yeah, the whole motor, yeah.
Now, it's my belief on the maybe the other side of the equation, the deck isn't quite as thick.
Okay.
And I did it's hard to measure the depth of the deck.
Yep.
Because it's not perfectly, the backside is a bunch of castings, but I took the depth of the threaded holes, because some of these you can get your finger down below and put a mic down in there. Yeah. So I came up with in some cases almost 1/10 of an inch less thread here. So like 0.7 instead of 0.6. So this would have like 0.6 and that one had 0.7. Huh. I didn't find any holes on this one that were deeper than that one. So it's the same in some cases and at least some less in other cases. So the deck is not thicker. And I think in an earlier video I said I thought the deck was thicker. But at least my measuring, Ed knows I don't measure all that good sometimes, but
you're good enough.
Good enough.
Yeah.
To measure the hole.
I think I have a t-shirt sometimes that says, "That's good enough, we quit." It says on my shirt.
So that's about as much as I can share on the weight and some of the areas that you can see, maybe more metal, maybe less metal. One of the things we didn't talk about, and I think you can post a picture of this, but the back of this block has been modified. Yeah. The French application of this had a big casting, I don't know, pad, I'll call it, back here on the back. And it was used for, who knows, but I've heard oil governor, I've heard safety switch, I've heard other things, but nonetheless, it was big, bulbous thing. And it doesn't work very well for guys putting these in hot rods because the firewall of a car is right in this area.
Okay.
So this block was modified before I got it. And you can see, if you look close, this has been sprayed with like red primer, different than the block was sprayed.
I see, right. That
and you can see a few machining marks on here.
The texture
is different. This is much, when you show the picture of the block as it comes, you can see the significance of what's been done back here to make this block more usable for hot rod.
Okay, so even though this does stick out a little bit, it's way less than the original.
I would say that'll work.
Yeah, okay.
There's a firewall, like about here.
Sure.
This pad, the pad, I don't know exactly what that was for, probably to stamp some numbers. This says 89, so I'm guessing that's when this block might have been made.
Yeah, I see the 89. That's a good guess, I would think.
It doesn't have the anti-chatter rods. Usually there's a hole right through here for so I'm guessing that the truck application didn't need them. But some guys that are using them in early Ford cars in the United States do drill that and machine it for the anti-chatter or stay rods. At some
There's rods, anti-chatter rod. There's a rod that goes back to the frame here, about that long. It's a pretty good sized rod, and there's one on both sides. So when you push the clutch pedal down, it don't push the whole motor forward.
Okay.
Because the motor's on motor mounts, rubber motor mounts, and it was easily, if the motor mounts get wore out and stuff, you push the clutch pedal down, the motor would go ahead of 1/2 inch.
Oh man.
So that don't make the clutch work very well.
Right.
So they put these anti-chatter rods, and I think they've been in there forever.
The being sort of a hot rod flathead guy myself, I wanted to see the performance potential.
Yep.
And so I was looking hard at the ports, right? And also the cylinder walls. Supposedly there's a lot of material here that can take a much bigger bore.
Okay.
We talked about earlier in one of your videos about this. This is a factory relief.
Yep.
It looks a little different than the sort of crude ones that we saw that Ford did. This is actually looked like it's machined with a CNC machine.
This down here between the ports and remove the metal so the air flows better.
Yeah. This relief is much more sophisticated looking, isn't it?
However, as we know,
Yeah.
this would not be a overhead valve conversion candidate because of that relief, because we need it to be flat across there for the head gasket to seal.
And by overhead valve, you mean Arden?
Arden. There's a few others, actually,
okay,
but
all right.
I was actually referring to our earlier video on Arden.
Yes,
that's right.
Right.
So Arden conversion, probably not a candidate.
Yeah.
The port size, did a bunch of measuring. I've got this one sort of with some red marks up here. It measures exactly the same across here as the Ford blocks, and I would say I measured all these blocks, and I think that it's the same as the Ford block.
Okay, all right.
But huge difference down here in what's called the bowl area. This is the valve seat, and they use 1.5-inch valves all the way across. So the seat's no different than the Ford Flathead. But I put a red mark on a ledge right down in there.
I see it.
With a Sharpie. So it's neck down considerably down below the valve seat area.
It is.
And it's smaller by over 1/8 of an inch.
Huh.
So for the performance guy, you would clean that area up anyway. You would just have to clean it up a whole lot more.
I see. Okay.
I went ahead and put a lifter in. Feel that ledge in?
Yeah.
I went in, not a lifter, but a valve guide in there. So it is the same relative height to the floor where I have my finger back here as a standard flathead. So the extra material is right there. So that would make the ports smaller.
Smaller, yeah.
Of course, it's a truck. It probably doesn't get over 2,500 RPM anyway. So having smaller intake ports is maybe what they wanted. Maybe that was even intentional. So those bowls are smaller than the standard flathead.
Okay.
But the opening size, same. My favorite part about the ports are the exhaust ports. Quite a bit of improvement, in my opinion. One of the, in my opinion, significant improvements on this block is the exhaust port. I'm gonna go ahead and let this.
He's just showing off his engine stand now.
It's pretty nice.
Only one in the world.
One of the really bad parts of the flathead for performance are these actually all the exhaust ports, but the end ones especially. And here's why.
Okay.
So the exhaust, this is an exhaust port. For the exhaust to get out of the motor, it has to, one, come up out of the cylinder, make a 90-degree turn, another 90-degree turn, another 90-degree turn, and then when it gets here, it has to make another 90-degree turn. It's almost impossible for the exhaust to get out of the block.
Wow.
And what makes it even worse is, I'm going to show you this one over here.
Okay.
Is there's a ledge in there. You know what I'm talking about?
Yeah.
It's flat. It's like they.
No way.
It's like they on purpose don't want. So put your finger like right here. I know your viewers can't see it, but feel how that's flat. Right?
Oh yeah.
Like right here. So the exhaust comes around there and hits that. I call it a dam. It has to make a turn, but it runs right. There's no contour in that at all. In addition to it being a shelf, put your finger right here. Feel it as rough casting, real rough.
Oh yeah, you can cut yourself on it.
Cut yourself on it.
Yeah, right. Wow.
So when you port these blocks, you do the best you can to smooth all that out and then radius that exit, but that shelf is there.
Right.
And there's nothing you can do about it.
Right. Right. Okay.
So now come over and look at this one.
Okay.
Right there is a nice contour out of there.
Oh, that's a world of difference.
It's like night and day.
Wow. Yeah.
Check it out, Ed.
Oh, that's huge.
That limitation, that shelf right there, is a huge limitation on flow out of that motor.
I think that's solid cast behind that.
Yeah.
So you can cut it out. You spent a lot of time cutting that out of there.
Wow.
This is a huge hole here.
It is. And it's contoured, right?
It's smooth.
It's made to flow way better. So that's an improvement. That's an improvement.
I would think so, yes.
So another improvement, and I couldn't figure out a good way to measure this, but I'll show you with my my little measuring rod here.
Okay.
So we know that this center two exhausts share this passage down the middle.
Yes, quite
And
famously.
and it has to go between these two cylinders.
Right.
So this rod is just small enough that it'll go, see I have to actually work it through there, but it'll go through there.
Mm-hmm.
And I can put my finger, I can reach the top of it. So it goes through there. And I would say if you move it back and forth, maybe it's 10 thousandths or so. It's pretty
tight
in there.
Yeah.
So make the same comparison to this.
All the exhaust has to go down that hole.
The two middle
The
ones.
two middle ones, yeah, two middle ones.
So this one doing the same thing.
Oh, yeah. So obviously much bigger.
Huge.
It's almost a quarter of an inch.
It's almost twice as much flow.
Yeah.
Yeah, almost twice as much
Because
flow.
you're buying the 1/4 inch on the outside diameter, so that's a lot
right.
of space.
Yeah, yeah,
Yeah, and it's actually more of a rectangular opening
Okay.
yeah.
than round, but
Yeah.
that's just the difference between the two.
Wow.
Isn't that
So,
something?
so there's significant difference.
Yeah.
Yeah.
Now this,
Up and down.
yeah,
Yeah, see there? That's
Now
a
this
lot for two exhausts.
this is a ported.
One at a time.
Yeah.
This is a fully ported motor here,
Okay.
and the clearance is similar to the French block.
Okay.
Somebody's,
That's
that's
had
been
some-
worked on a lot,
A lot of machining.
but that hasn't been touched.
Isn't that something?
So the exhaust ports are way better than the stock. No matter which year flathead you pick, those ports, exhaust ports, are way better,
Uh-huh.
significantly better.
Right. Are you surprised at that?
Yes, absolutely.
I was
It's worth buying.
So-
it's worth buying that block just for that reason.
It's a lot of improvement on the
Yeah, a
exhaust
lot
side.
of improvement,
Wow.
especially with the it's already ground on this side. The ports are bigger, and
So we could
yeah,
clean up the intake bowls. You're going to do that anyway if you port it.
Yeah.
So you just clean them up more.
Yeah.
Exhaust, way better. And then, of course, I would put a more modern relief and a deeper
yeah,
relief on it.
Yeah.
a little different on that because you put the gasket on it and match up the gasket.
Now, is this, I'm maybe way off. Is this relief?
That's a hot rodder.
That's a hot
relief.
rodder relief
Yeah.
right there?
That's not a
Yeah.
factory relief.
Right. But that's more the way
More
you
the
do
way
it?
I would do it. Yeah.
Yeah. Okay.
There's one more important thing.
Okay.
Oh, two maybe.
Okay.
One of the things that, and I have a friend in California that's built a lot of these, and I called him up, and he said that he gave me a couple things to watch out for, and one is this right here. This bolt hole, it's a head bolt.
Uh-huh.
Normally it's the head bolts or studs, whatever you use, are threaded through the deck of the block,
Right.
including that one on all the Ford motors. But on this one, it's not threaded in the block. There's threads in this exhaust passageway.
Oh, you're kidding.
So the head bolt actually goes into the exhaust.
It needs to be longer bolt.
Longer bolt, and it goes through the water and to the exhaust.
No way.
What I understand people typically do is they'll make a plug for the exhaust port. So plug that lower hole and put some type of threaded insert
coil on the
here
top.
or a time
And
server.
separate the two.
Separate the two, yeah.
Yeah.
So that's a difference that you got to watch out for.
Wow.
And I was asked, well, how did Simca do it? How did they? And I don't know.
Okay.
I've heard there's an O-ring and a seal. I don't know how they do it, but
That's crazy.
it's different, right?
It's different, yeah.
Yeah.
So you have to drill this out for a helicoil, which is bigger.
Yeah.
And then insert your screwed in plug
Plug.
that goes in the exhaust.
Yeah.
And put your helicoil after that.
Yep.
And seal it into the water jacket.
Now you're
it
back-
can be done.
You're
It's just
back. You're back to what what Ford had.
Yeah, that's
yeah,
right.
It's two spaces. You have to seal the two between you.
Yeah.
And that's the only bolt.
Yeah.
That's unique. But you better know that.
You better know that. Here's another thing to know about. On all of the Ford flatheads, the exhaust manifold bolts are dry. They go into the casting, but not into the water.
Okay.
On these French blocks, all 12 exhaust bolts are wet. They go right into the water passage. So I brought my screwdriver just to stick it up through here so you can see it right there in the water passage.
Sure can. Yep. That's
Another
wild.
thing to know, right?
It's to seal, put the exhaust bolts in, you have to seal them. Or put studs in them. And I would probably put a sealed stud in it
Yep.
and stud them and then put nuts on them. And don't take the bolts in and out a lot. Just take the nuts off to change the exhaust. It'd
Right.
probably be a little bit easier too if you had headers on it. because it's easier to take that nut off that short stud than to take a long bolt out.
Yep.
Yeah, so it's a lot easier. It's best to put studs in them.
It's my understanding that the French had studs, sealed studs in the blocks. And I meant to say this, but all of these fasteners are SAE. I thought,
they are.
I thought maybe coming from France, maybe they would be metric.
Metric or Wentworth.
Every fastener on here is SAE.
SAE. Wow,
Now, interestingly, the studs that they put, it's SAE where it goes into the block, but the nut was metric.
Yeah.
So they had metric nuts on the end.
Yeah.
Somebody said that the lifter towers, the bores, whatever, are higher in the block than the Ford.
Oh.
They set up higher, and that perhaps you need to machine the top of the lifter bores. But I measured with my trusty stick here, and all I did is I went down through and put this on the top of the lifter bore and put a straight edge across the block.
Oh, yeah, yeah.
And then I put a mark. This black mark is the 59 block right there, and the green is this block.
A little difference?
Yeah, I
A
don't.
little bit.
The width of the Sharpie. I don't
Yeah,
think that's enough for me to worry about, but
Yeah.
I guess if you're running a reground
difference.
cam and
It's
long
just
valve,
a difference, and
yeah.
sometimes it's good.
yeah, so I didn't see that was a major issue for me.
Mm-hmm.
Now, but I've heard that more than once. So people have machined the top of these to make it easier to adjust the valves, I guess. The lifters that came in these were super tall, and the valves were shorter by a lot, like 1/4 inch or more. And so the lifters clearly stuck way up.
Shorter valve and have a shorter spring.
Yep, everything is different.
Yeah.
And the lifter is not quite as tall as that Arden one we were looking
Yeah.
at, but it's a real tall. That adjustment's way up above.
Wow.
So I don't know.
Probably in there, because there was always a problem adjusting the adjustable lifters
Yep.
down there, because we drill holes in them to
Yep.
hold them with the Allen wrench,
Yep.
so we can actually get a wrench on an adjustment. If they made the lifter taller,
Yep.
then you could get a wrench to hold it,
Yep.
1/2 inch wrench maybe to hold it, and a 7/16 to adjust it, and solve that whole problem.
I was thinking if the tower is slightly taller, maybe because they're using a taller lifter, maybe
Yeah, it could
maybe
be
they
that.
made it taller.
Yeah,
All right.
Interesting.
My last thing, I believe, is underneath.
Okay.
So I'm going to flip this over.
It surprises me how much difference there is. You know, because somewhere, maybe they got the molding and the castings and some of this stuff from Ford, and it would be hard to change that. To change these ports and to change some of these things, this many things on one casting, if they did get the casting and the molds from Ford originally, or I would think it'd be almost impossible for them to make their own. That'd be a big deal to make their own for the Flathead.
They made them for almost 40 more years.
Yes, they did.
So they had an opportunity to learn and adjust as they went,
and possibly modify.
And sometimes the tooling wears out, and if you're going to do new tooling, might as well make it better. I wanted to point out here on this block is the difference in the main bearing, the center main bearing cap.
Okay.
This cap is off of an 8BA motor, one of these blocks over here at the side.
Right.
And it's typical of really about any of them.
Okay.
But this center main bearing for the French Flathead has a significant support cast into the main bearing.
Well, it's proud of it by a lot.
Yes.
Much stronger.
Yes.
Wow.
Wouldn't it? I don't know if we ever had a main bearing center cap cracked.
Yeah.
But that would be like almost twice as much stress on that cap without cracking the cap in half, or causing flex even too.
You look at the that thickness versus that thickness; it's significant.
That's much super good design.
Yeah.
And that's really awesome.
And this black stuff is that Cosmoline we were talking about earlier. I just didn't get a chance
to get it all off.
I started working on it over here, but that's kind of what this whole block looked like before.
Wow, that's
a
lot of work.
And as Ed said, it doesn't clean off easy.
It takes the same oil pump and
oil pump,
pan gaskets.
Gasket.
Pan. It's got some kind of a breathing system up front. I think. Change the pan.
Yeah, the French. Probably. I don't have a pan for this motor, so it's hard to talk about those differences. But there are some differences in the pan.
Okay.
But certainly you can make a 59 early style Series 1-2 pan work on this block.
Okay.
Yep.
Great.
So, Barry, I think, and Ed, that's all I think I had today.
So yeah, it's really interesting.
That is very interesting. It's funny, at a quick glance, they look the same.
They look the same.
You study it, and it's quite a lot of differences.
Yeah, and there's probably differences I haven't figured out yet, but I have crawled over it quite a bit.
Yeah.
And at least I know some of the differences, and I look forward to getting that book I mentioned.
And the same thing, I think, on some of the things. The rod length is the same.
Same rods.
So the deck height is the same. That means from the block to the center of the crank. That's all the same. So
it's my understanding that all of these were 4-inch stroke cranks.
Oh, okay.
So like the Mercury crank.
Uh-huh.
Same 239 bore, but with the 4-inch Mercury crank. So it'd be 255s.
255 cubic inches.
Yeah, that's my understanding. All of them are that way.
Yeah.
That's my understanding.
If they made that much production work and changes, it was only common sense that they just put the 4-inch crank in it.
And for a big truck,
horsepower and torque out of it.
Yeah.
It's only common. Yeah, good job for them.
Yeah.
I like that.
Yeah, me too.
Well, thank you so much. This is a lot of fun, and I'm sure people are going to comment, and it's going to be fun to see what people either might know beyond what we've been able to find out, or ask more questions. We'll see how it goes.
Yeah, I look forward to getting those comments, because I learn from the comments as well. So please, if we got something wrong or I missed something, please point it out.
Yeah.
And Barry, we'll see you next time.
Right on. Thank you, Steve. See you later. And thank you, Ed. Guest appearance at Steve's place.
Yeah.
Thanks for being a part of BarryTsGarage. And if you want some Ed Smith memorabilia, some hats and shirts and all, it's just edsmithspeed.shop. Head over there and have a look.